Hello everyone. Welcome back to my YouTube channel. This is Neha SD, currently pursuing BE in Sri Venkateshwara College of Engineering. Library number 23CS1920, section BMW, subject Mathematics, and the topic is Application of Partial Derivatives. What are partial derivatives? Partial derivatives are a way to measure how a function changes with respect to one of its variables, while keeping the other variables constant. It is denoted by the symbol delta f divided by delta x, representing the rate of change of the function f with respect to the variable x. This concept is particularly useful in multivariable calculus while dealing with functions that depend on more than one variable. The applications of partial derivatives. First, in the field of physics, economics, biology, engineering, finance, and the computer graphics. Introduction. Partial derivatives, a fundamental concept in calculus, find widespread application in diverse fields, providing a powerful tool for analyzing the behavior of the functions with multiple variables. In this comprehensive discussion, we will delve into the myriad real-life applications of partial derivatives spanning physics, economics, engineering, finance, biology, computer graphics, and beyond. Physics. In the realm of the physics, partial derivatives play a very important role in understanding the quantifying changes in physical quantities. Concerning multiple variables, for instance, consider heat conduction in material. The partial derivatives of temperature with respect to a spatial coordinates helps describe how temperature varies throughout the material. This insight is crucial in designing efficient heat dissipating systems and optimizing thermal properties in various applications. Furthermore, in fluid dynamics, partial derivatives help model the behavior of the fluids in motion. The rate of change of velocity with respect to a spatial coordinates yields important information about the fluid flow, fascinating the design of aerodynamic structures, predicting weather patterns, and optimizing the transport systems. Economics. In the field of economics, partial derivatives are instrumental in analyzing and modeling economic systems. Consider a production function that depends on multiple variables such as labor and capital. The partial derivatives of the production function with respect to each input variable provide valuable insights into the magical productivity of factors of production. This information is crucial for business and policymakers in optimizing resource allocations, determining optimal production levels, and understanding the impact of the changes in input quantities on output. Next, in the field of engineering, engineers extensively apply partial derivatives in various disciplines to analyze and optimize systems. In structural engineering, for example, the partial derivatives of stress and strain with respect to a spatial coordinates are used to understand the distribution of forces within a structure. This information is crucial for designing safe and efficient buildings, bridges, and other infrastructures. In electrical engineering, partial derivatives help model and analyze the behavior of the circuits. For instance, when studying the transient response of an electrical circuit to a changing input, partial derivatives aid in understanding how voltage and current changes with respect to time. And the next, in the field of biology. In the biological sciences, partial derivatives are applied to study complex systems and processes. Enzyme kinetics, for example, involves modeling the rate of enzymatic reactions as such as a function or a substrate concentrations. Partial derivatives are employed to understand how changes in substrate concentration affect reaction rates, providing essential insights into the mechanisms of the biochemical reactions. The partial derivative of population growth models with respect to variables such as birth rates, death rates, and resource availability help ecologists understand the factors influence changes in population size over time. And in the field of computer graphics. In the field of computer graphics, Partial derivatives play a crucial role in rendering the realistic images. Shading models, which determine how light interacts with the surface, often involve calculating gradients using partial derivatives. This information is essential for creating visually appealing and lifelike images in computer-generated environments. Texture mapping in computer graphics is another application where partial derivatives are employed. By calculating the partial derivatives of the texture coordinates with respect to screen coordinates, graphics algorithm can map textures onto the three-dimensional surfaces accurately, enhancing the realism of the virtual scenes. Next, in the field of geophysics, partial derivatives are extensively used in geophysics to analyze seismic data and model subsurface structures. When interpreting seismic waves, the partial derivatives of the wave velocity with respect to the spatial coordinates help geophysics to characterize the composition and geometry of the geological formations beneath the Earth's surface. This information is vital for applications such as oil exploration and earthquake hazard assessment. Conclusion. In conclusion, partial derivatives are a versatile and indispensable tool with applications spanning a multiple of disciplines. From physics to finance, engineering to biology and beyond, the ability to analyze the quality changes in the functions with respect to multiple variables has revolutionized our understanding of complex systems. As technology advances and interdisciplinary research flourishes, the applications of partial derivatives continue to evolve, shaping the way we approach and solve real-world problems. This exploration provides a glimpse into the vast landscape of possibilities that arise from the elegant and powerful concept of the partial derivatives. Thank you.